Hey there. In this video, we are going to look at factoring trinomials by grouping. Now, we will actually start by looking at when it's already in four-term format. But in order to factor a trinomial, which is 3 terms by grouping, we will need to turn it into a 4-term polynomial first. So before we do that, though, let's talk about how we actually factor by grouping when it is 4 terms. So we'll start with number 1 here. We see 2x squared minus 4x plus 5x minus 10. Now, you see the common factors or common terms here, rather. And those, typically, we would combine those to simplify it all the way. But when we are factoring by grouping, we need 4 terms to be able to do that. So I'm going to leave these as 4 separate terms. And we are going to break this into the first 2 terms and then the last 2 terms. So we're going to look at those separately. And we are actually going to find the GCF in each one of those. So starting with just this 2x squared minus 4x. So let's start with 2x squared and negative 4x. Notice they both have a 2 and a 4, which are even numbers, and then they both have an x as well, x and x squared. So starting with the number 2 is going to be the greatest common factor in terms of the integer that we can pull out of each of those, divide out of each, and then x is going to go with that because we have an x and an x squared. So 2x is the GCF in the first pair here. And then looking at our second pair, we have 5x and we have negative 10. So 5x and negative 10, those have a common factor of 5. They can both be divided by 5. They do not both have an x, so we can't pull an x out with that 5. So that's step 1 in grouping. After we have it already written as a 4-term polynomial, which we'll talk about how we do that in the next example, we first start by doing the GCF of each pair, first 2 and last 2. Now, once we've done that, we go ahead and rewrite the first pair and the second pair using the GCF, just like we did back when we factored by GCF. So we have 2x, and then we'll put a set of parentheses. And to figure out what goes in the parentheses, we will do what we did with factoring by GCF. We'll divide each of the terms in that pair by our GCF. So 2x squared divided by 2x, 2 divided by 2 is 1. X squared divided by x to the first power will just be x. So you can put 1x or you can just put x. And then we have negative 4x divided by 2x. Negative 4 divided by 2 is negative 2. X divided by x simplifies or cancels out. You can think of it either way. Simplify to 1, which 2 times 1 is 2, or we can cancel them out, however you want to look at it. Then we do the same thing here. Now, the key thing that you want to remember when you go to do the second pair, we have to put a sign in front of that GCF. So whether it's positive or negative, we have to put the sign that goes with it. So here we're going to have plus and then the GCF for the second pair, so plus 5. And then a set of parentheses, and to figure out what goes in there, we divide each of those terms by that GCF. So 5x divided by 5 is going to be x, and then negative 10 divided by 5 is negative 2. So that is our next step to pull out the GCF and see what's left over when we divide out that GCF. Now, something to point out with grouping. These must be identical for grouping to work. So it's possible that a 4-term polynomial is not factorable by grouping, but how we know that is based on these sets of parentheses right here. Once you've divided out your GCF, are those 100% identical? Not close, not kind of close, but exactly the same. They have to be exactly the same in order for this to work. So once you confirm that they are the same, then we are looking essentially at this term here and this term here. So again, we're looking at those because we see a repeated factor. We see that x minus 2 is part of both of those terms. So what I can do is I can go ahead and actually pull that out like another GCF. And that's going to go in front, x minus 2 here. And then we think about, okay, if I divide this term by x minus 2, by pulling it out, it's no longer there, and I'm just left with 2x. If I divide this term over here by x minus 2 by pulling it out, it's no longer there, and I'm just left with plus 5. So we have x minus 2, the repeated factor, and then the GCFs, 2x plus 5 in the second set of parentheses. This is the factored form of our original polynomial, 2x squared minus 4x plus 5x minus 10. So again, that is the factored form of that longer polynomial that we started with. And you can check it by distributing it back. So if you did x times 2x, x times 5, negative 2 times 2x, and negative 2 times 5, you would see that you would end up with an equivalent polynomial to what you started with. So in order to factor by grouping on a trinomial, we will need to turn the trinomial into a 4-term polynomial, and we do that by splitting the middle term, the x term. So we're going to always look at that x term and break that into 2 pieces, and that's how we are going to factor by grouping. Now, sometimes factor by grouping is not the most efficient method. I'm going to start by showing you multiple problems that could use factor by grouping, but we'll also see guess and check when A is 1, when A is not 1. We'll see other methods coming up. And so when you look at solving quadratics, which will be the end goal here, when we look at eventually solving quadratics, we have a lot of tools that we can use. And depending on the problem that we're presented with, different tools may be more efficient than the other. So it's important to know all of them because there's some that it works better for each method. And I'll talk about that as we go through. But I want you to see that you can use it on many, many problems. It's just sometimes there are more efficient methods depending on the problem. So let's take a look at number 2. So on number 2 here, we see x squared minus 7x plus 12. So x squared minus 7x plus 12 is a trinomial. There are 3 terms. So in order to break up this middle term into 2 separate terms, and we're going to leave x squared and we're going to leave plus 12, we need to figure out 2 numbers that combine to be negative 7x. And they have to multiply to something specific as well, which we'll talk about in a minute. Now, we can't just randomly pick, for example, if I did plus, let's see here, we'll do minus 5x minus 2x. While those would combine to be negative 7x, when I go to do factor by grouping with that, you'll see that if I pulled out the GCF here, and I'm doing this quick because it's not going to help us, which you'll see in a minute, I would end up with this, and we would see that these do not match. So that tells me that I cannot continue with factor by grouping if those don't match. So what I need to do to ensure that I pick 2 numbers or 2 terms that combine to that negative 7x, but still will get me to be able to group, I need to not only make sure that they add to that negative 7x, but they also need to multiply to our a times our c. So a is the number in front of the x squared, which is going to be 1, and then c is 12. So 1 times 12 is 12. So we need to think of the factors of 12. So let's start there. And I'm not too worried about the sign right now. So yes, this time it's positive, but we're just going to go ahead and look at, in general, 12, whether it was positive or negative. The factors of 12, so 1 and 12, 2 and 6, 3 and 4. And if you look at those factors, we want to find a pair of factors that we can either add or subtract in some way to give us negative 7. And that's that middle coefficient there. So 1 and 12, I can't add or subtract to give me negative 7. 2 and 6, I can't add or subtract to give me negative 7, but 3 and 4 would work. So 3 and 4 I'm going to use, but if I just do 3 plus 4, that's positive 7. So I need to do negative 3x and negative 4x. And it does not matter at all, as long as you pick the right numbers, it does not matter at all which order you put them in. It will work both ways. So let's take a look. Now that I have 2 numbers, 2 terms that multiply to a times c, which is 1 times 12, negative 3 times negative 4 is positive 12, and add to negative 7x, negative 3 plus negative 4 minus 4 is negative 7x. I have not changed the problem mathematically. I have only changed what it looks like so that now I can go ahead and group like we did earlier. So I go ahead and pull out our GCF in the first term, which is going to be x, And our GCF in the second pair is going to be -4. So I put that x in front, and then I divide each of these terms by x. X squared divided by x is going to be x minus 3x divided by x. Those x's cancel out, and it's just x minus 3. And then once I have that, remember the sign has to go with our second GCF. So in this case, it is a negative number, so -4. And then once we divide each of these terms by -4, we see what we're left with. So -4x divided by -4 will just be x. 12 divided by -4 is -3. Remember that these sets of parentheses have to be 100% identical. And in this case, they are. So what that means is we can go ahead and pull that x minus 3, that repeated factor in front, to be x minus 3 out front. And then our GCFs are what we're left with in our second set of parentheses. Our remaining piece is x minus 4. So x minus 3 times x minus 4. If I were to multiply that out, that would get me back to this trinomial that I started with. So let's do another example like that. X squared plus 3x minus 18. X squared plus 3x minus 18. The middle term is 3x, so we need two terms that add to 3x, and they need to multiply to a times c. And remember, a times c is going to be the number in front of the x squared, and then the constant at the end here. So 1 times -18, which is going to be -18. So I'm going to start with the factors of just general 18, 1 and 18, 2 and 9, 3 and 6. 4 doesn't work, 5 doesn't work, 6 is already on my list, so that's all of my factors of 18. And I remember I need them to multiply to -18. So that would mean that in each pair, one of them is going to have to be negative, either 1 or 18, 2 or 9, 3 or 6. But before I worry about that, I look at 3x. So I'm going to go through my factor pairs, and I'm going to see which of these pairs of numbers that multiply to 18 also could add or subtract in some way to give me 3x. So 1 and 18, there's no way to do 1 plus 18, 1 minus 18, 18 minus 1, any of that to give me 3x. 2 and 9 are never going to add or subtract to be 3x, but 3 and 6 will work. So if you think about how do I get 3x or 3 in general from 3 and 6, 6 minus 3 gives us 3. So 6x minus 3x would give us 3x. So I can use 6 and -3. And that's going to multiply to -18. So 6 times -3 will be -18. And then 3x is what it adds to when we do 6 plus -3 or 6 minus 3. So we break this 3x into two separate terms. We leave the x squared at the beginning. We leave the -18 at the end. And now we have either plus 6x minus 3x, or you can do minus 3x plus 6x. It doesn't matter which way you write it. So let's go ahead and factor by grouping now that we have 4 terms. So we're going to group the first two and the last two together. So when we do that, the first pair has x as the GCF. The second pair has a negative. Notice they're both negative here, whereas in the first pair, they're both positive, and we need the signs to be the same so that eventually those parentheses match. So I'm noticing now that I need to pull a negative out with the GCF, and then -3 specifically is going to be our greatest common factor here. So when we do that, we put an x in front here, and then we have x squared divided by x will be x. 6x divided by x over x simplifies, so that's just going to be plus 6. Our GCF, our sign needs to go with it, so -3. When you divide each of these by -3, we get positive 1x, or just x. And then -18 divided by -3 is going to be positive 6. And again, our parentheses do match here. X plus 6 matches x plus 6. So that means we are good there. And so our final step is to pull out that x plus 6, that repeated factor in front. And then our GCFs x and minus 3 are left over in that other set of parentheses. So x plus 6 times x minus 3 would be your answer on this one. And it does not matter. So depending on where you put the 6x and the negative 3x to start, in which order you put those, you may get a different order at the end, and that's okay. Because it's multiplication, it means the same thing both ways. So let's take a look then at number 4. So notice number 4, we have 2x squared plus 6x plus 4. So number 4 is a little bit different because we have an a value in front that is not 1. The last two was an a value of 1. We are still going to approach it the exact same way. So we need two terms that add to the middle term. So they need to add to 6x and they need to multiply to a times c. And in this case, a times c is going to be 2 times 4, which is 8. So again, that first coefficient and then the constant at the end here. So 8, the factors of 8 are 1 and 8 and 2 and 4. And so I need to figure out how can I get 6x by adding or subtracting one of these pairs. 1 and 8 will never add or subtract to give us 6, but 2 and 4, we can get 6 from that. And we need them to be positive 6 when we add them together, and we need them to be positive 8 when we multiply them together. So they are both going to be positive because 2x plus 4x gives us 6x, and 2x times 4x gives us 8x squared, which is a times c. So what we do is we break that 6x into two terms, leave the 2x squared at the beginning, leave the plus 4 at the end, and we have our 2x and our 4x. Again, doesn't matter which order you put them in. If you put 2x and 4x or 4x and 2x, that does not matter. And then we factor by grouping by looking at the first two and then the last two pairs. So our GCF of the first two are going to be 2x. The GCF of the second pair is going to be 4. And then at that point, we divide each of these by 2x. And we'll divide each of these by 4. We have 2x times, and then when you divide the first term, we get x plus 1. 2x divided by 2x is not 0. That's a common mistake, so make sure you put the plus 1 there. And then our GCF is 4, positive 4, so plus 4 times x plus 1. And notice again, our sets of parentheses are matching. So what that tells us is that we can go ahead and pull that out as our repeated factor. And so that's going to be x plus 1. And then our GCFs left are 2x plus 4. Now, something I want to point out here that's important. Technically, this is not fully factored all the way. 2x plus 4, those are both even. So we could actually divide out a 2. And we can't just divide it and say, oh, it's gone, because this is not an equation where we can balance that on the other side. So what we do instead is we factor out a GCF out of this set of parentheses right here. So this is going to be rewritten essentially as 2 times x plus 2. By pulling out that 2, we divide each of these by 2, and we're left with x plus 2. But we still have that 2 in front, so that we didn't actually mathematically change the value. We just rewrote this 2x plus 4 as times 2 times x plus 2. Typically, that whole number is going to be in front, and then we can leave it either as x plus 1, then x plus 2, or you can switch the order of the x plus 1 and the x plus 2. It doesn't matter, but this is going to be your actual final fully factored answer. So if they're asking you to factor all the way, this would be your fully factored solution. When we get to solving, then we'll talk about how you could solve for x at that point. Okay. Now, another point I want to make really quick. If you notice back at the beginning, they are all even. You could have actually divided each of those by 2 to begin with and factored out a 2 at the beginning. So it would have been x squared plus 3x plus 2 when you divided that 2 out. And then we would have just been factoring this trinomial, and you could have factored that by grouping instead so that you didn't have to do it at the end. Either way, you're going to have that 2 in front when you factor that out. So factor by grouping, you do need 4 terms. If it's a trinomial, remember we split that middle term, and we do that by figuring out how we get it to add to the bx, which is the middle term, and it needs to multiply to ax squared times c, or a times c. Okay, and that's how you figure out how you split that middle term. And then once you've done that, we figure out the GCF of the first pair and the GCF of the second pair of terms. And then once we've done that, we pull out the common factor, and we put the remaining terms in the other. Remember, those remaining terms are going to be your GCFs that you pulled out. So that's how we end up with those binomials at the end when we factor by grouping.